This is problem 643 from the textbook. This is a truss problem. You're given this truss system, which I've drawn here at the top. They want us to find CD, so the forces and whether it's tension compression for CD, CJ, GJ, and CG. And so the first thing we want to do is look and try to, or first see if there's anything that's zero force members. So we have this, let's see. So for zero force members, we have this DJ would be a zero force member, and then also this BH would be a zero force member. And then I think that's going to be all of them. And then we have to decide how we want to approach solving this. So we could do method of joints. If we did that, we need to solve for, say, E, and then we can do joint E, then joint D, or joint E, and then joint J, and then joint C, maybe. So it'd be 3 joints. We do method of sections. We could cut the section here, and then that would give us GJ, CJ, and CD. And then we'd have to do a method of joints for joint G to get that CG to solve for that. I think that'll be a little bit easier, and we're practicing method of sections, so we'll just do that for now. So if we take that right side of it, we are going to need to know what's going on at E. So let's start with the free body diagram for the whole system. I'm going to copy it because I've already drawn it out on my iPad. This is one of the things that makes it a little bit easier about doing it on a tablet. So I'm going to do this, and for the free body diagram, we want to remove the reactions. So I'm just removing them here and replace those with forces. So at A, we're going to have that normal force at A. And then at E, we're going to have EY and have an EX. Now we can do any of our 3 equations of equilibrium. We can sum the forces in the x direction equals 0. That's going to equal EX, because that's the only force. Then we can sum the moments about point A equal to 0 to find that EY. So we sum the moments about A, we'll take coming out of the paper as being positive, which is also counterclockwise. And so at A, that 4 kilonewton force is at A, so it doesn't have a moment or produce a moment. The 6 kilonewton force will produce a negative moment. So it's going in this direction. So 6 kilonewtons, I'll make it negative 6 kilonewtons times that perpendicular distance, which is 1.5 meters. And then the 12 kilonewton is also a negative moment, times that perpendicular distance, which is 3 meters. Just going to write without the kilonewtons and meters. The 9 kilonewton force is also a negative, so 9, and then that's 4.5 meters. Is that perpendicular distance? And then minus that 6 times 6 meters. And then plus that EY times that 6 meters. And then EX was just 0. And there's no moment arm, so it wouldn't matter anyways. Equals 0. And so now we can solve for EY. Calculator. Sorry about that. Go ahead and calculate that out. So then we get EY equal to 20.25 kilonewtons. now we can take the right hand side of that section and draw a free body diagram there. Let's see, I'm just gonna maybe grab this. So we have this, the right hand side of the section. Let me draw that back in. But basically, we then have a force here, which would be the GJ. We have a force here, which is the CJ, and then a force here, which is the CD. And EX equals 0, and EY equals the 20.25 kilonewtons. And now we have 3 unknowns, and we have 3 equations of equilibrium. So we can sum the forces in the x direction, the y direction, and sum the moments about a point. I'm going to start by summing the moments about this point J, just because 2 of the unknowns are at J, so we'll be able to solve for that CD. So I'm going to sum the moments about J equals 0. The same out of the board as being positive. So then we have, about J, we have that 6 kilonewton force, and it creates a negative moment. It's into the board, 6 kilonewtons times 1.5 meters is that perpendicular distance. And then that EY is 20.25, and that creates a positive moment times that 1.5 meters. EX is just 0, so that doesn't do anything. And then CD will create a negative moment, and CD times, and then that one is written there, that was 1 meter. 1 meter equals 0, so CD is going to equal equal 21.375 kilonewtons, and that's going to be in tension. And then, so that's one of the ones that we need to find. And then we can sum the forces in the x direction and the y direction. Both of the unknowns have x and y components, so we're going to have to do both. And we'll have 2 unknowns in each of them. So sum of the forces in the x direction equals 0. We get negative CD, which is at 21.375, minus that y component of that CJ. And I forgot to put the measurements in there. This is 1 meter and 1.5. So here's 1 and 1.5. So I'm multiplying by 2. So 2 and 3. And so this will be the square root of 2 squared plus 3 squared. So 4 plus 9 is the square root of 13. So the x component of that would be 3 over the square root of 13 times CJ. And then minus, and then that from J to G is 1.5 meter over and 1 meter up. So that's also 3 and 2 and square root of 13. So minus 3 over the square root of 13 GJ. And then 9 is in the y direction, the 6 and the EY is all in the y direction. EX is 0, and CD is in the CD we already got. So that equals 0. So I'm just going to solve for one of them. So I'll say CJ equals negative 21.375 minus 3 over square root of 13 GJ. All that times square root of 13 over 3. So we get CJ equals negative 21.375 times the square root of 13 over 3 minus GJ, just because those cancel out. And then we can sum the forces in the y direction. And we get that y component of GJ, so that'll be 2 over the square root of 13 GJ minus CJ times that y component of CJ, so 2 over the square root of 13. And CD is in the x direction. We have minus 9, that's all on the y, minus 6, and then plus 20.25 equals 0. And so then we basically get, let's see, 2 over the square root of 13 GJ minus, and then I'm just going to plug this CJ into there. 21 or minus 21.375 square root of 13 over 3 minus GJ times 2 over the square root of 13, and then minus 9, minus 6, and plus 20.25, so that'd be plus 5.25 equals 0. And so now we get 2 over square root of 13 GJ plus 21.375 times 2 over 3. The square root of 13's cancel out. And then plus 2 over the square root of 13 GJ plus 5.25 equals 0. And we end up getting, this is 4 over the square root of 13 GJ equals negative, I'm going to go and multiply those out. So that equals minus 19.5. So GJ equals minus, it's at 19.5 times the square root of 13. And divided by 4. So we get negative 17.58 kilonewtons. And so that means that that's actually in compression, because we guessed tension, so 17.6 kilonewtons in compression. So now we have GJ and CD, and then we can also solve for CJ by going back up to this formula. So CJ equals negative 21.375 square root of 13 over 3 minus GJ, and it's minus, and I need to use this value because we didn't change the drawing, so minus negative 17.58, so that equals negative that plus negative 8.11 kilonewtons. So CJ equals 8.11 kilonewtons in compression. So we guessed wrong with that one also. So now we basically have the CD, GJ, and CJ. So we have the first part of it. We also need to find that CG. So to do that now, we can go to joint G. and solve for CG. So we get to go to joint G. Yeah, it'd have to be joint G, because joint C we would have 3 unknowns. So now go to joint G. In joint G we have, so notice now we're having to pull in that method of joints. So 12 kilonewtons. GH. CG, which is the one that we're interested in. And then GJ. GJ was 17.6 kilonewtons of compression. And GJ we know is in that, it's 2, 3 square root of 13. And the same here is 2, 3 square root of 13. We're going to guess that one's in compression too. And then we don't know what's CG. I'm just going to make it in tension because I'm not really sure. And so we have basically 2 unknowns here. So let's sum the forces in the y direction. Well, actually we'll sum it in the x direction first and get GJ. Because both GJ and G are in the y direction. So that'll give us 2 unknowns. So we're going to have to solve for GH also. But sum the forces in the x direction equals 0. And we'll get that x component of GH. So that'd be 3 over the square root of 13 times GH minus 3 over the square root of 13 times 17.6 kilonewtons equals 0. So basically all that cancels out, so GH also equals 17.6 kilonewtons, and that is in compression. That's not actually one they asked for, so that's why I didn't box it. And then CG, so now I can sum the forces in the y direction equal to 0. And we get that y component of GH, so 2 over the square root of 13 GH minus CG plus 17.6 times 2 over the square root of 13 minus 12. And GH is also that 17.6, so we get 2 over the square root of 13 times 17.6 plus 2 over the square root of 13 times 17.6 minus 12 equals CG. So CG equals, grabbing that 17.6 out of the right solution,